Hi, my name's Tom. I'm one of the people who has helped design this learning experience for you. Just want to take a few minutes and visit with you about a couple of things that are involved with it, because I'm sure you must have lots of questions. We've really designed this so that it's supposed to be a learning experience for you, not a schooling experience. Probably going to be unlike many other things that you've done in school or out of school. But we hope it will be exciting and engaging and challenging for you, and that in the end you will have learned a lot of physics as you go along. So let me get started. Some of the things that you may wonder are, what's this course anyway? Well, this is basically a physics course. It's a physics course that would be comparable to a physics course being offered in any pre-college program, except it's got some very unique differences. First of all, it's designed for you who are what I might think of as rocket kids. You're the ones who are interested in space and space science, and you have a real passion for knowing what's going on. We're really pleased to be able to do this with our partners at NASA too, who are providing a lot of the content for this first part of the course for the Virtual Learning Magnet. It's organized around 8 big ideas in physics. These were developed by a colleague of ours, Dr. Walt Snow, who is a physics teacher, both virtual and on ground, down in Gwinnett County, Georgia, just outside of Atlanta. Dr. Snow has a lot of experience working with physics for many years at all different levels and with all sorts of different learners. It's got these 8 big ideas that everybody should know. Then it's got some subtopics within each of those. So I'm sure you have a lot of basic questions. One of them, for instance, would be, well, how am I supposed to learn these things? Now that's the tricky part, right? Because what you have to keep in mind from the very beginning is that this is about learning. So we want you to be doing whatever you can to learn these physics concepts. When you've learned them, you'll go on to the next thing. It doesn't matter how long it takes you. If you can do it quickly, if there's some things, for instance, like scientific notation that you may already know really, really well, we expect you to move very quickly through those to get to other things that you're not quite as proficient with yet. So how will you learn? Well, the answer is any way you can. Any resources that we can make available to you to help you learn these concepts are what we're after. We've provided a number of resources already in the content repository, as we're referring to it. But you're probably going to be saying, well, I know that from this place, or I could add in this or that, and that's fine too, because you know what? Those resources may be available and helpful to somebody else all the way down the line. Another question you might ask is, who's going to help me? In a traditional course, whether it's a bricks and mortar course, as we call it, or a virtual course, you usually have one teacher. Well, with this course, anybody can help you learn. Some of you may not have much need for a teacher at all. This may be something that you are so proficient with already that you just breeze through it. On the other hand, we will have some certified physics course teachers available to you. They'll be helping you along the way, but not like a traditional teacher. This isn't one of those cases where you have one teacher and 25 or 30 students and they all go through at the same pace. This is a case of who can we bring to bear to help you learn any particular idea. There will be times when you are involved with NASA scientists, maybe either directly or indirectly. Other resources that NASA has available will be what we're calling on to help you learn. We've also worked with an organization out of California that's part of the open source project. They've got a ton of resources that we're going to be using as well. So who's going to help you? Well, there will be certified teachers available, but don't depend upon them to feed you everything. We want to see what you can learn and how we can make that possible for you. Well, if you're learning, then we ought to be able to assess that, right? So another question you might have is, how will I be assessed? How am I going to be graded? That's something that's important for everyone. Well, I could go into great length about this and about some of the things that we're trying to change. But let me just tell you that, first of all, we don't want your grade to be the prime motivator or your prime worry in this course. The people who have designed this course, the people who are here on board to help you learn, have your learning as their goal. It's not like, oh, you're going to do Big Idea 1 and take a test, and if you get an 83 on that test, then that goes into some sort of a grade book that is going to be averaged up at the end. What we're looking at is, how can we help you learn these 8 big ideas and the subtopics and sub-ideas within those, so that you're proficient in physics, so that you've learned the physics that you need to. There are a lot of ways that you'll be assessed during the course, but they're all going to be sort of ongoing assessments. We've got some reflective elements provided for you. So before you begin any topic or subtopic, you'll be asked to think about that. And think about some questions like, what do I already know about this? How could I learn more? How is it useful in the study of space science? What can I connect it to with physics that I've already done? And then afterwards, we'll also be asking you to show us evidence that you've learned that. Now, one thing that I've always heard is that a lot of people distrust online learning because they say, and I'm just going to be real frank with you, they say, well, kids could cheat. Somebody else could do the homework for them. Somebody else could take the test for them. This is about learning. It's not about working through a course, not about getting a certain grade on a test so that your GPA isn't hurt. This is about learning. If you, for instance, if somebody were, for instance, to say, get some help on one of the early ideas, kinematics and one-dimensional motion, and then later it became evident that you didn't really know one-dimensional motion the way you should, what happens? Well, it's not we dig up that grade from the past and put it in front of you somehow and punish you with it. It's just that, hey, you know what? Hey, Tom, it looks like you don't really understand this concept in the depth that you need to. So let's go back and look at it again until you do, because that's what we want to help you do, is learn something well enough to be able to go on. So each of the things you learn is designed to be sort of a gateway into the next thing. If you don't understand it well, it doesn't help you in the short term, and it certainly doesn't help you in the long term. So don't be afraid to ask for help. Don't be afraid to have to do something again. Try it until you understand it, until you learn it. So how will you be graded? Each of the ideas carries with them what we call a gateway assessment. One thing that you learn opens up new things and new opportunities, right? So your gateway assessments will be largely a design and of a nature that you figure out. How do you provide evidence to anybody that you know what you're talking about, that you understand a concept? You may want to produce a little video that we put on YouTube. You may want to do a podcast. You may have a project that you do. You may want to work through a series of problem sets that Dr. Snow has designed. Somehow, we just need you to provide the evidence that you understand that concept. So, another question, what should you be doing on a daily basis? This isn't like you have a textbook that you're going to open up and start in on page 1 or page 7 and work through all of the exercises and all of the readings. What you need to first of all be doing is keeping up. We want to design this and have you help us design this so that it's high interest for you, because we really believe that's what keeps people motivated. Don't let things lag. Just because we're not starting this course with definite timelines involved, we look at it as our responsibility as the adults working with you is we need to make sure that you don't fall so far behind that you're able to fail. So we'll be working with your mentors to make sure that you keep on a minimum schedule. But the neat thing is you can work ahead as far and as fast as you want. The more you learn, the better we are, the better we like it, because the more we have helped you to succeed. So we're not going to let you fall behind. You can move ahead as rapidly as you want. So keep up. Be part of the controllers of the learning. Make sure that you're involved in the learning decisions that come along. If we say, hey, I really don't know that you know wave theory well enough, we expect some dialogue back and forth where you say, oh, wait a minute, you know what? I was looking at this NASA video about how they do training for the astronauts in the underwater environment, and I noticed that I could describe that mathematically and with physics concepts in this particular way. Well, that might not have been something that we had thought about, but that was one of the ways that you could show us your learning. So it's those learning decisions that we expect you to be part of and taking an active role in. Finally, I would ask that you contribute to the content repository. One of the other unique things about this kind of a course is that you're not just taking things from it and regurgitating back. We expect you to be contributing to the content repository so that later on down the line, another student who's trying to learn something may actually be using the resources that you put into the content repository. I'll talk more about each of these ideas, or hopefully one of you perhaps will help in the video making and can talk more about this later on. Good luck!